All right, welcome to CARES. If you are unfamiliar with CARES, we are the University of Cambridge's research center here at CREATE. Some of you might be more familiar with us through our flagship C4T program, which started in 2013, related to decarbonizing Singapore's chemical industry. However, we do also host another large program called CLIC, which is what I will be introducing today. CLIC, the Center for Lifelong Learning and Individualized Cognition, is a collaboration between the University of Cambridge and Nanyang Technological University, or NTU for short, that brings together multidisciplinary expertise from neuroscience, linguistics, and education into the investigation of mental flexibility. This is an ability which can ensure individuals remain adaptable, are able to develop new skills, and remain resilient in their careers. Our speaker today, Associate Professor Victoria Leong, is a developmental cognitive neuroscientist who is a principal investigator and co-deputy director of the CLIC program. She will be presenting how CLIC researchers are developing a neuroscience-based model of flexible learning to inform the design of practical interventions in schools and the workplace. And with that, I shall hand this over now to Prof. Leong.
Thank you very much, Olivia, for that introduction. I'm really pleased to have this opportunity to share some of CLIC's emerging work with you and to connect with you across the globe. So good afternoon, good morning, wherever you are, and welcome to the seminar on becoming a lifelong learner, the importance of mental flexibility. So before I get going with the scientific content proper, I want to make a very important point that the work I will be presenting is not my own. I am representing an incredible and fantastic team of international researchers across Cambridge University and NTU, some of whom you'll get to meet later in the Q&A chat part of today's session. So CLIC brings together really a wealth of expertise across the fields of psychology, cognitive neuroscience, social and language sciences, and also education in a very deep multidisciplinary collaboration on the science of learning. And as a team, we are committed to delivering world-class science to address today's most urgent global learning challenges. Now, as a developmental neuroscientist, I can tell you that learning starts before birth. It starts in the womb. But maybe the question for us today is, when does learning end? Or in fact, does it end at all? So back in the good old days, in the traditional model of employment, it was the case that our schools and our universities taught us just about everything that we would need for work. So formal learning effectively ended when we got our graduation caps and we left the university and we stepped into the workplace. And in fact, that was the hallmark really of achieving adulthood, when we were done with formal learning. But these days, that's no longer true. In today's era, we're witnessing a complete revolution and rewriting of the script towards the need for a lifetime trajectory of learning. And in today's current employment model, we no longer can expect to stay in one career all the way from the start till retirement age. Rather, workers must expect and be prepared to train and retrain multiple times for different careers. And of course, this places incredible cognitive demands on us for learning and relearning well into our middle age and even into our later years. And these changes are happening because of the rapid pace at which environmental and workplace challenges are emerging. And this comes with it both opportunities as well as challenges at multiple levels for us as individuals, as organizations, and also as countries. So on the global stage, our nations are facing these urgent and often pernicious challenges in the form of climate change and crises in renewable energy and food security. And this requires, at a global cooperative scale, creative reinvention and strategic repositioning. At the meso level, our companies, universities, businesses, and organizations, we're all grappling with the technological revolution in AI, digitization, and automation. And it's estimated that about 375 million workers may imminently face some form of career change or disruption because of these new technologies that are entering our lives and our workplaces. And of course, all of this unease and change bleeds itself into our personal lives, and it may exacerbate a sense of insecurity or a lack of confidence in our future. So in the face of all these workplace challenges at different scales, how then do we build a workforce that is resilient and adaptive? And at a more personal level, how do we ensure our own psychological well-being and health amidst these external challenges? Well, I don't have a panacea to offer you, but at CLIC, we are shining a spotlight on a particular cognitive skill that may perhaps be undervalued, but may be potentially the most helpful in helping us become creative and resilient lifelong learners. And this skill is called cognitive flexibility. You may have heard of its more famous siblings, memory and inhibitory control or self-control, but actually there's a third sibling in the family of executive function called cognitive flexibility, and that's what we're going to talk about today. So in organizational psychology, it's already fairly well known that flexibility and adaptability are essential for overcoming workplace challenges, particularly when these are unexpected or when we need to put into place contingencies. So we need to pivot quite quickly. And the wider research suggests that there is a consistent and positive relationship between people who have higher cognitive flexibility and their career adaptability and entrepreneurship orientation, specifically of innovation in their businesses. So let me give you a more concrete picture of what flexibility looks like in the workplace or why we might actually need it in our day-to-day situations. So here's just a snapshot of some situations where we need to be flexible. First of all, in creative problem solving. So particularly when we're faced with new situations or problems that we haven't encountered before, we have to extemporize or make up a new solution. And this creativity, this novel generation of solutions does require flexibility. Also, as alluded to earlier, we're increasingly facing the need to adapt to many new technologies, just changes in our workplace systems, having to work from home rather than from offices, and a myriad of other small changes that means we have to adapt the normal schemas that we are familiar with. And all of this, again, requires mental adaptability or flexibility. It's no surprise, and also probably many of you experience this in your everyday life, that there are many demands on us to multitask. You know, we spend the day switching constantly between one type of task and another type of task. We're typing an email here, we're writing a memo there, we're counseling a student there. And, you know, all of these are different task demands that we have to switch between. Maybe a more relevant example is when we switch between Zoom calls. These days, it's not unusual to have 6 Zoom calls in a row, and the gap is really only a few seconds. And you have, in that space of a few seconds, you have to reorientate yourself to what's the history and the context of this meeting? Who am I talking to? Is it students or is it ministers? What am I trying to achieve? And all of that has to happen so rapidly within just the space of you clicking a button. So we're multitasking like never before. And finally, although this might not seem obvious to you, but even our interpersonal relationships require mental flexibility, because taking yourself out of your own shoes and into someone else's shoes requires a shifting in perspective. And that skill, understanding someone else's mindset, the development of that skill requires cognitive flexibility. So today's discussion, I hope I have illustrated, is clearly very relevant for skills in the workplace and in the real world. So all of these skills, however, are not very easy to teach in our schools, and we aspire to develop them, but it's very hard to develop a curricula that develops creativity in particular. And actually, our own data has shown a similar pattern. So here I'm showing you measurements in a cohort of healthy young adults that we took as part of the CLIC study. And what you're seeing in the orange bars is the distribution or performance of healthy young Singaporean adults for an intelligence test on the left-hand side and for a creativity test on the right-hand side. And we're comparing their performance against a global population of their peers shown in green. So on the left-hand side, you can see a very sanguine picture where it comes to IQ or intelligence. Singaporeans perform above the global mean. In fact, if you look at what our IQ is, it's very nearly 1 standard deviation above the global peers. So we're doing very well where it comes to scores on intelligence. However, the picture changes when you look at creativity. Not only are we maintaining our lead, we're actually falling behind. So the average creativity scores are just a little bit below that of our global peers. So putting this into numbers, we're in the 58th percentile for IQ, but only in the 43rd percentile for creativity. Translating this, it means that the average Singaporean worker is likely, not all the time, but likely to have relatively higher IQ, but relatively lower creativity than the average global worker. So this is hurting our global competitiveness. And it also tells us that we're not fulfilling our potential because relative to what we expect for IQ, we're underperforming in terms of creative potential. So how then do we strategically strengthen creative potential, innovation, and lifelong learning? Well, that's a topic that we're here to talk about, but it's also the focus of a review article that was penned by senior author Professor Barbara Sahakian, Dr. Christelle Langley, and myself in the popular journal, The Conversation. And here we pointed the finger on what might be the missing ingredient. IQ tests can't capture this, but maybe what we need to focus on is cognitive flexibility as potentially the key to lifelong learning and creativity. And this is because some of the greatest achievements in human history have relied on creativity and imagination. And it's exactly this cadre of skills, creativity and imagination, that seems to relate most strongly to flexible thinking. And that seems to dissociate from IQ, or what we call crystallized intelligence. And as evidence for this, if you compare two cohorts of individuals, successful entrepreneurs and managers who have similar age and IQ, then what differentiates these two groups of people is not their IQ, but their cognitive flexibility. Those who turn out to pursue careers in entrepreneurship and who show more creativity are the ones who also show more cognitive flexibility. And so this is why in CLIC, we're focusing on cognitive flexibility as the key. And we're aiming to train the next generation of flexible learners. And we have three key thrusts. First, in terms of the basic science, we have a neuroscience-inspired program that aims to understand how cognitive flexibility arises and to promote individual cognitive flexibility. We also want to embed this within the social and cultural context, particularly that of Singapore, and to understand the mediating role or moderating role that social factors play in the relationship between cognitive flexibility and programs that seek to improve this. And finally, we don't want to just stop at the science. We want to take this into the real world to have impact and translational value. So we're committed to making training and intervention programs that can have real life utility in our workplaces and in our schools. And that's our longer term vision. So let me now turn to the more scientific portion of my presentation. I've given you a very kind of layman's view of flexibility and why this might be important, but we also need to understand how we study this in the laboratory. So what is cognitive flexibility? It's our ability to adapt to change and to problem solve in new situations. Formally, we define it as the capacity to switch or shift our thinking from one conceptual representation to another. And these changes or switches can either follow changes in instruction, we're told to do it, or feedback, we realized this was wrong, so we change our actions, or sometimes it can happen spontaneously as well. In terms of the wider context, flexibility is thought to be one of a triad of executive functions. And like I said, you might have heard of the other two more famous siblings, working memory and response inhibition or inhibitory control. Cognitive flexibility is the third of that triad. And it's thought to be dependent on a network of frontal and striatal brain regions that observe these abilities. As we've already alluded to, cognitive flexibility is not the same as IQ. It's only weakly correlated with intelligence. So it's not as simple as just being clever. There is something else to being cognitively flexible. And also, unlike IQ and the other EF skills, there's a low heritability for cognitive flexibility. And this suggests that it may be especially potentially malleable by environmental influences. And this means that training programs could have a bigger impact because of this malleability by environmental input. And this is why also we've chosen flexibility as a skill to focus on for intervention programs. So how do we measure flexibility in the lab? Well, we have curated a very comprehensive set of cognitive flexibility tasks, and I'd like to take you through them, as some of you might be curious as to how we estimate these skills in individuals. So there are 5 tasks in total, but here I'll start with 3 classic tasks because these 3 have a very similar structure. First, the participants have to discover a rule, and they learn this by trial and error. And then once they've got the rule, we change and switch the rule on them. And then we assess how quickly they can adapt their responses to this new rule. So that's generally true of these 3 tasks, but let me talk you through each one. So on the far left-hand side, we have the Wisconsin card sorting task. And in this task, participants have to match or sort their card to one of 4 possible options. As you can see on the screen, it's possible to do a match based on a number of different dimensions. The cards can be matched on color, for example, red, on shape, triangles, or on number. There are 3 icons in the response card. So at the start, the participant doesn't know which rule is the right one, and so they just have to guess. If the rule was in fact color, then the correct match would be to the far left card where you see the red triangle there. And the participants are told if their match is correct or incorrect. After they discover this color rule, we then switch the rule on them. Let's say we switch it to number. So in that case, if they kept sorting based on color, they would get an incorrect feedback. And again, and instead, they have to switch to matching based on number. And in that case, that would be the 3rd example with the 3 pluses. And so what we're interested in is how long the participants keep going on the old rule when in fact the rule has changed. This is what we call a perseverative response. And the higher or the longer they perseverate, the lower their cognitive flexibility. A similar logic applies for the CANTAB intra-extra-dimensional set shift task, which is the one on the far right-hand side. And so here the participants have to choose one of 2 possible response options. And at the beginning, it's a random choice. But in fact, at the start, they have to pay attention to the lines in the picture because only one of the white lines is correct. And when they learn this, we change that so that the other line image is correct instead. And then just as the final twist in the most advanced stage of this task, instead of responding based on the lines, they have to pay attention to the pink shapes in the background instead. And that's hard because up to this point, participants have had to ignore the pink shapes and now they have to pay attention to it. That's why it's an extra dimensional shift. The last task of this genre is probabilistic reversal learning, or PRL. And again, here they have to discover which of the 2 options is correct. But this task is also a little bit special because unlike the other 2 tasks where the feedback is consistent, which means that if it was correct, they'll be told it was correct 100% of the time. Here, the feedback is probabilistic. So for example, the red icon may be correct only 80% of the time, and the green icon is correct 20% of the time. So it's not 100%, and they have to learn and calculate these probabilities in order to guide their responses. So that's the first set of cognitive flexibility tasks. We have other tasks as well. And these are tasks in which we tell the participants what the rule is, so there's no ambiguity, and we even tell them when to switch. So for example, in the trail making test, participants have to connect the dots and switch alternately between letters and numbers. So they have to join, for example, 1A, 2, B, 3, C. So this is a systematic and an instructed switch between letters and numbers and letters and numbers. On the right-hand side is the task switching, set switching task, which is similarly switching under instruction. And here participants see a compound stimulus like K4. And depending on whether this is a letter task or a number task, they have to pay attention either to the letter part of it or to the number part of it. So if it was a letter task, they have to judge whether it's a consonant or a vowel. If it's a number task, they have to judge whether it's odd or even as a number. And which task they perform is cued with a visual cue. So they have to switch between different tasks based on a visual cue. So in CLIC, we use this comprehensive battery of tasks because no one task perfectly captures cognitive flexibility in all its richness and dimensionality. So we have multiple tasks, and from these many measures, we then extract the core common factor, EF, as a common component or latent factor across all the tasks. And that latent factor is what I will show you in the following slides for our results. So what are we doing with the cognitive flexibility measure? Well, in phase 1 of CLIC, we are running 2 major investigations, which we call in-house 0.1 and 0.2. And that's our nickname for the 2 studies. But what we're doing in these 2 studies is, first of all, in 0.1, we're asking how is cognitive flexibility related to all these practical life skills that are of interest to us? How is flexibility related to IQ, to creativity, to language and math, to social emotional skills, problem solving, and career adaptability? And we're doing this investigation with 2 cohorts, with adolescents, teenagers aged between 12 to 14 years, and with healthy young adults aged roughly between 18 and 30 years of age. So that's basically a characterization study of how these skills and constructs relate together. The second study is 0.2, where we're starting to pilot and look into a training paradigm that can help us improve flexible thinking across the lifespan. And as a teaser, that we're using the structured learning task, which I will get to a few slides from now. So you're going to hang on, you have to hang on before we get there. But first, let's talk a little bit about what our results have told us about how flexibility is related to each of these skills of interest. So first of all, to IQ. Well, I think you are probably relieved and pleased to hear that, like previous studies, we have found in our CLIC study that cognitive flexibility is indeed not the same as IQ. And in fact, compared to the other 2 executive functions, response inhibition and working memory, there is a lower coefficient or statistical relationship between cognitive flexibility and intelligence. This is the lowest or the weakest relationship out of the 3. So this tells us that training CF instead of memory or inhibition may indeed have unique impact, irrespective of the intelligence level of the participant. So this is consistent with previous literature and consistent with my hypotheses and proposals earlier that it's not enough just to look at IQ. Cognitive flexibility contributes something unique to the equation. Secondly, it's no surprise, and again, a relief to see that in our study, cognitive flexibility was related to classroom skills like language and numerical cognition. And in our study, we measured this with classic tests of achievement, like the Woodcock-Johnson test of achievement. And we found even after controlling for intelligence and the effect of intelligence, there was still a strong and significant positive association between higher cognitive flexibility and better performance in literacy and numeracy tasks. So again, this is consistent with the fact that having high cognitive flexibility leads to positive benefits in terms of classroom performance. I'm sure you're all curious about the relationship with creativity, as indeed are we. But before I get to the results, let me just tell you a little bit about how we measure creativity in the lab. This is an interesting one. So we start with the task on the left-hand side, which is called the Remote Associates Test. This is a measure of creative convergent thinking. And in this task, participants are presented with 3 words: age, mile, and sand. And their task is to think of one word that links or connects all 3 words together, which is why it's a convergent thinking task. So if you put your thinking hats on, you might realize that the linking idea is stone. So Stone Age, milestone, and sandstone, that connects all 3 ideas. And so to perform this task well, you need good convergent creative thinking. The other 3 tasks measure divergent thinking. And the classic example of this is the alternative users test. So in this one, we show the participant an everyday object, and their task is to generate as many users as possible for that object. So for example, if I showed you a coffee mug, then generating alternative users, you might say things like, okay, we could use it to hold toothbrushes, or we could use it as a stand for our mobile phones, or I could use it as a flower pot, or as a goalpost for my golf ball. So all of these would count as different alternative users, and the more they can generate, the higher they score on this task. In the TTCT or Torrance test for creative thinking, the idea there is that participants are given a line prompt, for example, that little inverted V-shaped stimulus, and they have to incorporate this into a creative drawing or a picture or design. And they're given free rein with whatever they want to draw. And so you can see on that image there, some examples of very creative productions indeed from participants. And so these designs are scored on dimensions like fluency, flexibility, originality, and elaboration. And finally, we also administered a verbal fluency test. And in this task, you're asked to generate as many examples as you can from a given category, like animals or letters. And there's a time limit for generating these examples. So these are the tests that we administered in the lab for creativity, and in an analogous approach to analyzing the cognitive flexibility results, we employed a latent factor analysis to distill down the core ingredients of creativity from these tasks. And so our results showed that the data could be well represented by a two-factor creativity model, which for ease of interpretation, we've called verbal creativity and imaginative creativity. And as you can see on the slide, we showed that there was a particularly strong relationship between the cognitive flexibility factor score and verbal creativity in particular. And of note, again, intelligence was not related to verbal creativity, again, underscoring that dissociation between IQ and flexibility, where in this case, only flexibility predicted creativity and not IQ. Okay, so far we've talked about these grand relationships, overall population relationships between intelligence, flexibility, and real-life outcomes like creativity, language, and math. But how does this look like for individual children in your classrooms? And what are the pedagogical implications for children who have different strengths and profiles in these different skills? So on the scatter plot here, we're representing that spectrum of individual differences. What we have on the x-axis is a measure of general cognitive ability, the Ravens score, where on the left-hand side is low and on the right-hand side is high. And on the y-axis, we're plotting their cognitive flexibility factor score. Again, low is poor and high is good cognitive flexibility. And it's very clear to you that in this group of adolescents, 12 to 14 years of age, there's a big spread in abilities, and there's differences in terms of how they score in flexibility relative to intelligence. So let me kind of deconstruct this a little bit for you and also talk a little bit about how we might treat these different populations of students a bit differently. So the students on the top right-hand side, color-coded in purple, are really the ones we want to nurture. These are the students with high IQ and high cognitive flexibility. They are our future innovators, our future entrepreneurs. And so these are the students who could benefit from opportunities, internships, and mentorships programs to maximize their potential. There's maybe not a lot more that we need to do. They're really on the path to success already with high levels of both skills, intelligence, and flexibility. Similarly, the ones coded in orange, just to the left-hand side, also have very high potential. So these are the ones, although they have lower IQ, so their scores on the Ravens are towards the left-hand side, they still have very high flexibility. And this could, express itself in them being very creative or very innovative. And so this is the population of students who may be overlooked in traditional assessments that only focus on things like language and math. But in fact, these are the ones who may be the entrepreneurs too, and maybe our Jamie Olivers or our James Dysons of the future. So similarly, we need to look carefully out for them and maybe hothouse their entrepreneurial and creative talents. The students below the line coded in blue and in green are the ones where there may be potential for training and intervention, particularly to improve their cognitive flexibility scores. So the ones in blue have high IQ and low CF, and the ones in green are low on both dimensions. And so those are the ones whom, in terms of CLIC, we would be most interested in terms of designing interventions that suit their particular learning needs and profiles. So it's important then to be able to identify who might benefit from training, but also it's important to know what training approach to use. So in the past, training for cognitive flexibility has been done. We're not the first to think of this idea. However, previous training approaches usually involve getting participants to repeat the tasks that I showed you again and again and again until they get very good at them. And that has been shown to work pretty well in some contexts. But here in CLIC, we think there is a better way to improve mental flexibility, and that's by getting to the core or the heart of the issue, and by changing the decision strategies that people are using when they're dealing with uncertainty and change. So what do I mean? So to get at this kind of core idea of what is your strategy for doing the task, we have to look at computational modeling techniques that allow us to extract parameters about decision making. So what I'm showing you here are results from 3 of the CF tasks, the top 3 that I showed you, Wisconsin, IED, and PRL, the ones that I said involve rule learning and switching. Now, I told you that these are the ones which are pretty interesting from the modeling perspective, but they are also the ones which turn out to be pretty difficult for Singaporeans. Why is that the case? Well, we don't perform very well under these situations. For Singaporeans, if you tell us the rule, we're very good at following instructions and carrying them out. But if you don't tell us the rule and we have to figure out the rule, and worse still, if the rule keeps changing, not all of us have the strategies to cope with this level of uncertainty. So if there is an unmapped problem space, we don't necessarily know how to navigate that in a systematic way. And also, if we find something that works, we don't quite know whether to stick with it or to keep exploring other options if there is a better way. And so this kind of decision-making strategy, stick or stay, is exactly captured in these modeling techniques. And the parameter that captures this very well is something called inverse temperature, or IT. Here you learn another acronym for IT, but in the modeling realm. So in the modeling literature, inverse temperature relates to the stochasticity, or how consistent or random someone's decision-making strategies are. On the high side, someone with high inverse temperature is showing a strategy where they're very consistent or very deterministic, which suggests a very exploitative strategy. And this idea is that once I find something that works, I'm going to go all in for it and I'm going to stick with it. By contrast, on the far low end of IT spectrum, that denotes a strategy which is a little bit more random and wandering around or exploratory. Now, at the very far low extreme, this may mean that participants in this task are just clicking boxes randomly, which is not necessarily a very good thing. But at the intermediate Warren levels, that's actually possibly a very adaptive strategy, because it could mean that they have a working set of rules, but they're keeping an open mind and they're keeping an eye out and sampling other options in a systematic way, just in case things change or there's something better. And they're not putting all their eggs in one basket. So that is also a very adaptive strategy. And as you can see in the scatter plot, participants' factor scores or performance overall on this task was indeed very closely related to or driven by these underlying decision-making strategies. So there's a potential here that if we change the decision strategies, that will fundamentally change flexibility and performance on these tasks as well. But I want to make the point that indeed, actually, both explore and exploit strategies are potentially beneficial. And I want to give you a real example of this. So Facebook versus Amazon. Facebook, of course, is well known as a social media giant. They built their reputation on social media services. And as they expanded by acquiring similar businesses, such as Instagram and WhatsApp. And this consolidated their strengths in social media, making them a giant in social media, but they really exploited and focused on this very narrow niche. And they were successful. By contrast, Amazon has taken a very different approach. They started life as an e-commerce business, selling everything online. But then when they expanded, they explored and expanded outwards into new territories for cloud computing, entertainment, and other genres of e-subscription services, which suggests that they have a more exploratory business mindset. And so clearly both are successful, and what works may depend on your particular business and your environment. But the key point here is that these decision strategies are crucial, and we think they're a fundamental component of cognitive flexibility that has hitherto been overlooked. And so we want to focus our training on these more deeper transferable skills, because we think that's going to make our training more generalizable than just getting someone to just do the tasks again and again. So how do we change these decision strategies? Well, our key and what we think will work is the judicious use of uncertainty. So why uncertainty? Well, first of all, it's how we learn in the real world. In the real world, nothing is perfectly certain, although we try and structure things to make them more predictable. But really, we very rarely get perfectly consistent feedback, and nothing is always rewarding 100% of the time. And so if we want to train people to be competent in the real world, we have to create learning and training scenarios that also mirror this environment of uncertainty. And this is where the structured learning paradigm comes into its own. So what is structured learning? So structured learning is learning about how our environment is organized and what is its underpinning statistical structure. An example of this is like learning patterns of notes so that we can predict how a melody ends. For example, da, 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 da. Now, most of you are hearing in your head how it ends because you found the pattern and you can predict it. Similarly, in language learning, we pay attention to sounds and meanings that go together, and that helps us understand other people and predict how they're going to complete their sentences. For example, daddy, mummy, bae. And again, most of you probably completed that in your head successfully. So when we find the pattern or the rule, it's very easy to then generate predictions and plan our behavior accordingly and optimally. And in fact, knowing these deep structures is also very helpful for generalizing knowledge to new environments that are similar but non-identical. Now, crucially, this is a data-driven form of learning. Instead of being told top down what the rules are, we have to discover them all by ourselves by looking for and evaluating probable relationships within the input itself. And the important thing is that we're not getting clean, perfect input. The input is a little bit noisy or a little bit uncertain. And it's this uncertainty that may be key to fostering learning strategies that make us cognitively flexible. So in the structured learning task, participants see a sequence of visual symbols that look a little bit like hieroglyphs. And after seeing a series of these syllables, they're prompted to ask, what comes next? And at first, it's really hard and people are guessing completely at random. But actually, the more they kind of internalize and view the series of symbols, the more it becomes apparent that actually there is some structure in there. And they begin to learn the structure and generate predictions. And so the key thing about this task is that people have to do this without explicit reward. You're not told every time you guess whether the guess is correct or wrong. In fact, you have to do this basically under a constant environment of uncertainty. And I think that is exactly what generates forces you to generate these predictions and forces you to keep your mind open and flexible. So instead of me talking at you, let me now show you a little video clip so that you can experience what the structured learning task looks like. And I hope this works. Okay, great. So you saw those symbols embedded in a very compelling story that you're in a spaceship traveling through space, and these symbols are an alien language, and you have to learn the language in order to communicate with them. Okay, so what are these statistics that you're trying to learn? Well, actually, this is Zoe Kourtzi's task. It's very clever, and it has adaptive levels of complexity. At the simplest level, what we're basically learning is the overall probability of occurrence for one symbol compared to another. So there are 4 possible symbols here labeled A, B, C, and D, and each of them are just very frequent or not frequent. But there is no relationship between one symbol's occurrence and the next. They're completely independent. So in this case, B shows up 72% of the time, but that's irrelevant to whether A happened before it or C happened before it. In the first order Markov model, which is shown in the middle there, the sequence gets more complex because each symbol is linked probabilistically to the next one symbol. So as shown in that structure there, A is followed by B with a very high probability, 80%, but it's only followed by C with a low probability of 20%. Similarly, B is often followed by C, C is often followed by D, and D is often followed by A. So this effectively generates pairs of predictable symbols, which the participants have to learn. We can make this even more complex in a second order Markov model, which then ends up generating triplets, which have a high probability of occurrence. And so Zoe's innovation here really is to employ, again, computational modeling to analyze the decision strategies that people use when they have to perform this very complex form of learning under uncertainty without feedback. And she identified that two strategies potentially can be usefully employed to perform this task. We call them maximizing and matching. And here you see the separation of those two strategies in these curves or learning curves, where the x-axis is time, and broadly speaking, the y-axis denotes some measure of accuracy. So the maximizers are shown in red, and they are adopting a very parsimonious strategy. They're basically going, what is the most likely response? And then they go all in on it. So for example, if A appears 80% of the time, once they realize this, they will keep pressing A all of the time, 100% of the time. So although this overestimates the real probability, the upside is that it guarantees you get things right 80% of the time, and it's pretty efficient. So this is unsurprising then why these maximizers in red learn the task very quickly and why they also do very, very well. However, by choosing just that one response, they might be missing out on changes in their environment because they don't sample other options. They're just pressing A all the time. So there's another strategy shown in the blue curves there, which we call matching. And here the participant is trying to match the responses faithfully to the exact probability structure of the stimulus. So if A appears 80% of the time, B appears 20% of the time, their responses will mirror this perfectly. They will press A 80% of the time and press B 20% of the time. This is harder work because they have to remember what's what and then, represent this accordingly, but it has the benefit of keeping them open in the long run to changes in the contingency in the environment. So do these strategies in the structured learning task relate to CF, and how do they relate? Well, first, I'm going to re-show you the plot that I showed you earlier, which is showing that very strong relationship between the strategies you use in the cognitive flexibility task and your performance on the cognitive flexibility task. So inverse temperature predicts cognitive flexibility. If I now swap out, instead of cognitive flexibility, I put strategy on the y-axis instead, and that's what you're seeing on the right-hand side, we see a similarly strong relationship. So we can now see very clearly that one's strategy or inverse temperature in the cognitive flexibility task is strongly related to one's strategy in the structured learning task. And in fact, this relationship is very strong. The effect explains 40% of variance in CF inverse temperature scores, which is a large effect size. And it suggests to us that when you adopt optimal strategies in the structured learning task, this is probably related to optimal decision-making or inverse temperature in the cognitive flexibility task. This is what we saw in the adults, and reassuringly, we saw a very similar trend in the adolescents as well, where that relationship explained 28% of variance in cognitive flexibility inverse temperature scores, again, a large effect size. So in both adults and adolescents, training in structured learning may be a very promising way to fundamentally change the temperature of your decision-making so that we can become fundamentally more flexible in the way that we think and behave. I'm just going to spend a few minutes now talking about what's in store for us in the future. So all the data I presented was from our first phase. We're now very nearly at the end of that. We've made fantastic progress, enrolling 400 adults, testing 500 adolescents, and developing a pilot intervention program that's been completed and tested on over 70 young adults. We've also managed to establish the validity of the cognitive flexibility construct, and as I've shown you, mapped out its relationships to these outcomes of interest and also to structured learning. So going into phase 2, we're very excited now because we get to focus our efforts on developing a training program. And we've called this CLICs, and it will be an enhanced version of the structured learning paradigm that crucially involves gamification parameters in order to enhance participants' motivation and engagement. In phase 2, we're also going to be paying much more attention and deeply integrating social factors in Singapore's context. For example, cooperative orientation, perceived social support, and multilingualism, and looking at how these influence things like adaptability and career transitions. Last but not least, we are a very neuroscientifically focused collaboratorium. And so to help us better understand the neurobiological processes involved with structured learning training, we will adopt a multimodality approach to integrate the data from the cognitive measures with 3 innovative imaging modalities, which are magnetic resonance spectroscopy, or MRS, multi-parameter mapping, or MPM, and resting state, MRI. And examining all these 4 modalities together will provide converging evidence for a potential biomarker that is sensitive to the intervention that we can use for future studies. So that brings me to the end of my talk, and I hope that this means you will have some questions and you'll want to engage with us further. So it is my pleasure now to hand back over to Olivia so that she can introduce the panel of members who will be on our Q&A team.
Yep. Thank you. Thank you, Prof. Leong, for the talk. Great. For this Q&A session, we have a few PIs present from each work group who will be available to answer questions. Prof. Annabel Chen and Prof. Zoe Kourtzi are the co-directors for CLIC, representing NTU and Cambridge respectively, where they oversee the project and provide scientific leadership for day-to-day activities. Prof. Chen will also be acting as our moderator for the Q&A session today. Prof. Kourtzi is one of the leads of the intervention or neuroimaging work group that designs and implements the structured learning training paradigm and also the MRI protocols. The school's work group and social work group work closely to lead and implement large-scale data collection in schools for the adolescent study and for the adult population. Dr. Teochew Lee is one of the leads for the school's work group, and Prof. Henriëtte Hendriks is the lead for the social work group, as well as a co-deputy director together with Prof. Leong for the CLIC program. Lastly, Prof. Trevor Robbins is CLIC's senior scientific advisor, providing supervision and critical guidance on the team's analysis and modeling approach. Prof. Robbins was very recently listed as one of Clarivate's highly cited researchers in the field of neuroscience and behavior. So without further ado, I will now hand this Q&A session over to Prof. Annabel Chen.
Thank you, Olivia. Well, we're very glad to have the opportunity to share with our audience today about our work on cognitive flexibility at CLIC so far. So while the audience are getting their questions typed out in the chat, perhaps I'm wondering if we could invite Professor Trevor Robbins to provide a little bit more background on the concept of inverse temperature that.
Sure, yeah. So I think one of the great innovations of this project has been to bring together some theoretical ideas in learning with traditional notions of cognitive flexibility. And this has been done through the computational modeling involving parameters such as inverse temperature, which captures this balance between exploitation and exploration. So this very important point that in an uncertain environment, it pays not to be complacent. You have to be able to switch your strategies and to monitor possible changes and environmental contingencies. So I think this discovery that the cognitive flexibility tests are linked to structured learning via this parameter is a very important one indeed. And I'm looking forward to seeing how this is instantiated in the brain in terms of the neural circuitry which controls or arbitrates this balance between exploiting what you already know and exploring what may be important in the future.
Thank you, Professor Robbins. I do see a question from the audience, a very interesting one. Says that my child is very good in math, but not in other tasks, and he isn't so flexible in trying out new things. So for fear of failing. So I wonder if cognitive flexibility is related to the fear of making a mistake, failing, perfectionism trait, or something related. So perhaps we could invite Dr. Chuli to address this in terms of in the school realm.
I think definitely one of the other social factors that we included in the study is also growth mindset. I think in growth mindset, we are finding some relationship in that too. In that is a child willingness to say that my ability can change, and it's actually not to be afraid of failing, but to take the next step. We always say to give the tool for them to build the confidence. So I think if we take from that perspective, I think it has something to do with the cognitive flexibility. But I think that relationship we can explore more, but definitely from an educator is related. Yeah.
Thank you, Julie. It's really interesting relationships, and indeed there are quite a lot of different measures that we are including in to understand more about cognitive flexibility. And one of the things actually is not talked about a lot, but perhaps we are also very interested in looking at this. I would invite Professor Hendriks to talk a little bit more about the social factors that we are looking at together with cognitive flexibility. Professor Hendriks?
Yeah, sure, Annabel. Thank you. So yeah, related to the question that was just asked, one of the social factors that we look at, we call tolerance of uncertainty. And we have a number of measures for that. And this has to do with something that we call a need for closure. So actually wanting to have a quick answer rather than trying to explore things, which has to do with feeling safe in some sense. And it also measures things through being happy to be open to other cultures and new ideas. And so it's very closely related to cognitive flexibility. So we certainly think that that is, you know, anxiety or not knowing or being uncertain would certainly be part of that. And the other social factors that we measure have to do with cooperativeness. And cooperativeness has a flip side, which is competitiveness. And you may need cooperativeness in some situations and competitiveness in other situations. And knowing when to switch between the two probably is also part of being cognitively flexible and adaptable. We also look at multilingualism, and one of the reasons for that is that there is a long-standing idea that if you are multilingual, then you might have a cognitive advantage, and that might be cognitive flexibility in the sense that you have to control your languages and you have to switch between languages. So we have a number of different measures that we hope we will be able to find interesting correlations with cognitive flexibility with.
Thank you, Henriëtte. We do have a question from Professor Talk in Austin, actually. So it's for Vicky. It's looking at learning beginning before birth, right? So perhaps you could comment on what factors promote cognitive flexibility in early infancy, and does this last into childhood and adulthood?
Wonderful. Thanks, Toppin, and good morning. Good to see you on the call. Well, as you know, the early life environment is crucial for fostering these skills and the development of these skills. Personally, I'm interested in at least two factors that could shape healthy development of cognitive flexibility and other executive functions. One of them is the quality of early social interactions and particularly parent-child relationships. There are certain forms of caregiving, for example, very responsive, serve and return, mind-minded types of communication that seem to have positive effects on development of these skills. That's one thing. But the other one, Henriëtte also mentioned, which is being exposed naturally to these stimuli where you have to learn about probabilities and generate predictions, much like in the statistical learning task. And that's naturally what the skills that we engage when we learn language. And so there seems to be an emerging relationship between early acquisition of multiple skills and your flexibility that's developing at the same time. Of course, this is something that's quite hard to study in older adults because those skills are already fairly mature. But at those very early nascent stages, when the circuits are still forming, perhaps this is a natural way of delivering the statistical variety that Zoe's task does deliver in the form of natural language input. So that's something which we are, as you know, interested in studying as CLIC as well. So great question. But having said that, it's never too late because training programs, can also work in middle age and at older age. But since you and I are developmental scientists, we're very, very interested in what we can do at the very early stages.
Thank you, Vicky. And we are quite excited that you'll be looking into this in the younger age group with some pilot studies to help us to tease all these relationships apart in upcoming phase 2. We look forward to that. Now we have another question from Arcadius. I hope I'm pronouncing your name correctly. A very interesting question where you're asking, there is a lot of talking about learning and memorizing on the occasion of talking about cognitive flexibility. And you're wondering if there are any studies about unlearning and forgetting previously acquired knowledge that may be invalidated over time. Is unlearning and forgetting something that can be trained to be more cognitive, for more cognitive flexibility in a person? This is a tricky question, but I will defer it to Professor Zoe Kourtzi's wisdom to see how we could address that. Zoe?
Thank you, Annabel. Thank you. Yeah, really interesting question. What is the best way really of learning? I think what we see through our research and results so far is that there's not one good way, and people approach the problem in different ways. And so what we are hoping to be able to uncover is these different strategies and these different ways that people approach problems, and really encourage them to be able to switch their strategies depending on the environment, depending on the needs, and depending on the social factors that interact. And based on this, we are hoping to harness this individual potential and guide people in strategies that support this flexibility.
Thank you, Zoe. Indeed, I hope we all are looking forward to the advancement of our program to address this in more depth from our research findings. We do have a couple of more minutes, and there's one more question in here. It's asking a follow-up question, actually, from the social factors that we are looking at. So do we know if there is a relationship between cognitive flexibility and emotional regulation? And is it possible to train cognitive flexibility in adults, assuming neuroplasticity? I could reassure you, yes, we do have neuroplasticity even when we are much older. And what is the best way for cognitive flexibility to be improved in adults, and what are the challenges as compared to children? Perhaps Trevor, would you like to take on this question?
Well, I think the basic plan we have is to use similar training programs for adults and children. I think basically obviously the younger brain is capable of greater plasticity, but there is still residual plasticity in adults, and I think we can easily work with that. In terms of challenges, I think that obviously that there are challenges for people who've been used to learning one particular skill. As Vicky said in her initial talk, we have to now change the zeitgeist about learning when you're adult to demonstrate to people that they are capable of new learning and changing with respect to new labour opportunities and careers in your middle age and even later. So I think there is an important social challenge that we have to meet there. With respect to the first question, the relationship between cognitive flexibility and emotional regulation, I think that's a really interesting question, and it's something that we haven't yet tried to address, but I think it's something certainly for the future. Thank you for that.
Yes, thank you indeed for that question. In fact, we are very interested to look at that in our adolescents school team data as well. Okay, there's one more question, and we are a little bit over time, but I think we can take on that last question. Is that if there were any specific reasons that Singapore was selected as a country for this study? Or was it to do with the added factor of multilingualism in a large majority of the population? Indeed, this is a very interesting local question. Maybe I'll invite anyone on the panel to take this up first. If not, maybe I could address, I think one of the interesting things, in fact, Professor Victoria Leong has alluded to in one of her presentation slides, and also very interestingly, reflecting some of the profile that we're seeing in our students in the school for cognitive flexibility as well as IQ. As we do know, I mean, on one hand is like, yes, we are very fortunate to have the funding to look into this in a very systematic, scientific way. That on the other hand is we do know our students actually score very high on academic achievement type of tests, and we do very well on the PISA scores as well. But one thing we are getting a bit concerned about is in terms of tertiary education and output, we are not seeing what we would hope in terms of creativity or in terms of the innovative output that we hope to see. And we are just wondering, like, how do we maximize this? And perhaps one of the concepts that we could harness on from neuropsychology is looking into executive function, and cognitive flexibility is something, as Vicky has shown in the slide, quite important to look into. So in that sense, yes, Singapore is a very rich place to look into that. And also your question about multilingualism in the population is a good one. That's also something what Professor Henriëtte Hendriks has talked about in terms of flexibility with multiple languages. So it is also a very good environment to start to look into this in a more systematic way with a lot of data from different levels that we are collecting. Perhaps I'll give it back to the panel to have a few more comments on this.
Well, I think one point I would make is that the government of Singapore have this great vision to fund innovation in education and this type of training. I think it's absolutely amazing. So that is one of the main reasons that Singapore has invested in this very important area.
Thank you, Trevor. Professor Hendriks, do you have any comments on the multilingualism?
Yes, I think Singapore obviously is a very interesting place to do this kind of research from the perspective of a linguist. I think what we've struggled with is that traditionally people have seen a kind of bimodal way of thinking about lingualism. So you have monolinguals versus multilinguals. And we've now come to the conclusion that that is not the way of looking at this, and that actually it's scalar. So there's hardly any pure monolinguals left in the world. And there are many more multilinguals, but at very different levels. So you might know a bit of French, you might know a lot of French, you might know 3 or 4 or 5 languages, etc. And Singapore is very interesting because everyone is almost by the way in which education works, bilingual, but not only that, the whole culture surrounding individuals is multilingual. So you go on the metro in Singapore and you will get announcements in 4 languages systematically. You look at any of the signs and they're all in 4 languages. So even if you do not actively use those languages, you still are surrounded by them and get some input from them. And we think that, contrary to what we used to think, that it's just about the use of the language, that actually the passive information that you get and surrounding of other languages will probably also influence your executive functions.
Thank you, Professor Hendriks. I think we are about time, and we would really like to thank all the audience for joining our webinar today, and I'd like to thank all the panelists we have on here, and especially our speaker, Professor Victoria Leong. I'll pass this back to Olivia. Thank you.
Yeah, thank you, everyone. That was a really good Q&A session. Well, it's 6 p.m. Singapore time today, so I think we can say thank you, everyone, for joining us from various parts of the world as well, to the speakers and Q&A members for your time. And yeah, I hope everyone enjoyed the talk. There are still the links in the chat box if you want to follow us on social media and keep up to date with our work. So yeah, I'll say goodbye to everyone now. Yeah, thank you and goodbye. Okay.
Bye.